This is geotrig lesson outline 1, day 1. Today we're going to talk about points, lines, and rays. So, actually, before we get into these definitions, there's actually one I should probably add to this. And before I get to a line segment, we should probably get to what is a line. So a line. Now, I'm not going to necessarily write out in words the full definition here, guys. I am going to say it. You guys can obviously replay the video over and over to catch it all, or just open your book to lesson 1 and read it right out of there. But a line. Now, if I ask you, hey, what's a line? Most of us say, oh, it's straight. Well, isn't by definition all lines are supposed to be straight? Right? If it has a curve in it, it's a curve. Right? So lines are straight and they go on for ever. So here's a cool thing. I can make a line right there. And I can put points on my line. Is that okay to put points on my line?
Of course.
The shortest distance between 2 points is a straight line. Well, that's interesting. They use the word straight line. But go there directly. It's a straight distance. So if I wanted to name that line, what would one option be for that line?
Line AB.
Line AB. So how would I denote that with letters? I would put AB down, right? And what goes above it?
A line.
A line that has double arrows. So that would be line AB. So if I went to a line segment, is a line segment a full line? No, it's a segment. It's a part, right? So a line segment, you would say it's a part of a line. What differentiates that from a line and a line segment then? What does it have? An end. How many ends? 2. So, a line segment has ends. I can use this. I'll use different letters for this one. C, D. So now we can talk about line segment C, D. There are 2 options for this one. When I want to denote it, C, D, right? Put the letters there. And then I can put above it, put a straight line. Sometimes you will see just a line with no arrows. That is line segment CD. Or they actually, some books, things, actually put the actual dots. But it's really straightforward and say, oh, that's definitely a line segment because it's a picture of a line segment, yeah? Congruency. What does it mean to be congruent?
Like equal.
Equal. Okay? Equal. How about same? Congruency, guys, is like more than equal. More than same, I guess. It's kind of hard to picture that or realize that. Is the fact that if things are congruent, they are identical. So everything, okay? Everything about them. So if I wanted to say 2 triangles are congruent, because we're going to be doing that this year, that means they have identical angles and identical sides. And they're in the same places. They correspond with each other. Which means I should be able to pick up one object, place it on top of that other object, and you would never know the difference. Okay? That is congruency. What does it mean to be a ray? What's a ray? A drop of golden sun, yes?
So cheesy.
Yeah, that works. What's a ray? What's a ray look like?
Line. Popcorn answer.
Kind of like a line. But the line goes on forever? At only one end. So, a ray, guys, starts in one place and goes forever in the other direction. So we technically could have, I could have two dots here. I could call this ray AB. The B in there is just representing the direction. It helps you kind of lock in that direction. B is not the end point of the ray because it's by definition rays don't end, right? It goes on forever. Just like line AB goes in both directions past A and B. This one starts at A, goes past B, but through it. So if I'm going to call it something, I just put a little arrow one direction. Notice the ray starts at A and goes to B. When I denoted it, where's the start kind of point above? It's above the A and going towards B. This is a different ray. That's going the other direction. So this is not what we have pictured. It's a proper notation, but it's not the same. Which leads us to the next one. What's the origin? Beginning. Yeah. Now, if I was talking about an XY plane, the origin is at 0, 0. So this is just the beginning. So the origin of that ray is A. Where does it originate? What does it mean to be collinear? I am collinear right now with Ella, Rachel,
Even.
Charles, and Luke.
Even.
Even? Okay. But we're all collinear right now. I'm collinear with these guys back here, we'll say. What does it mean? It's not, we're really not collinear back here, but for all intents and purposes, I'm collinear this way too. What does it mean?
Lines at the top of the code.
Lines up? I like the line part. How about all on the same line? So, all on the same line. So, to be collinear means more than one thing is on the same line. So, watch what happens when I go all the way back up to the top. I put an F inside line segment CD. C, F, and D here are all collinear. You see that? Here? Okay, that's what it means to be collinear. Intersection means to intersect, right? Intersection. Meet. They meet up. They touch, right? So when we're talking about a system, like our problems from our review, the intersection of two lines is a point. Point of intersection. Two lines can have an intersection. Two planes, not aeroplanes, but planes in math, can have an intersection. We're going to talk about that in a second here. Next one we're going to talk about is the plane. No, we're not an aeroplane, but in mathematical terms, this board, right here, this board we're writing on and stuff, this is a plane. Your desktop is a different plane. The floor is another plane. The walls. It's a 3D space, but it's flat. Okay? That's a plane. I'm going to erase that. Okay? Does that make sense? Hopefully you didn't scribble all over your paper trying to show that.
Desk, for an example.
Example, your desk. An example, the XY plane. Everything we graphed, right, on our XY planes, that's a plane. It makes a 2D plane. Oh, actually, plane's a wow. Let me rephrase that. I'm going to correct myself. It's a 2D thing.
Okay, yeah, that makes a lot more sense.
2D.
I was gonna say something.
When we add 3D, it was when we start adding the third plane. Sorry. Yeah, my bad.
It's an arrow plane. Yeah, it's 3D.
Okay, to be co-planar, which means you're on the same plane. The words on the same plane are coplanar because they are all on the board. They're all on that piece, right? Skew lines are lines that never meet. Okay, lines, okay. There's a huge distinction here. Lines that never meet, but are not parallel. Because parallel lines never meet, right? Now, it's hard to show this on here. Wait, maybe I can. Would you guys agree, all intents and purposes, those can be parallel?
Yes. Nope. Sure.
Here's the thing. They're parallel, but they're on the same plane. So, skew lines never, they have to be on different planes. That's basically what it comes down to. X cubed would actually be a single graph.
I mean, were they both on different sides of the portion?
But generally, when we're talking about the origin and we're graphing, you're on on a single plane as an XY chart. And so either you're going to intersect, you're going to be parallel, or you're going to be the same exact equation. So at that point, would not qualify as skew. So remember when we ever did systems of equations, 2x2s, like the one we did on the board here, skew is never an option. When we start to get to a third equation, now we start getting off a single plane and start moving on different ones, then you can be skew. So there's either, for us right now, for what you know, there's one solution, many solutions, or no solution. Skew is never an option. Skew, guys, is as if you took an arrow, okay, so I'm trying to think, hold on. It's going to be tough. It's tough to draw this. I'm going to try my best. Give me some time here. Okay. If I had your XY plane, right? The board. If I came through here and I asked you to graph a line, you could graph a line like so. Yes?
Yeah.
Positive slope, has a positive y-intercept. Now visualize this. This is a little difficult. What if I took an arrow from where I'm sitting back here and shot the board with the arrow? That's the point. That's what I'm trying to get at. I'm going to miss. I'm going to miss the line, probably, right? More than likely, I won't hit that line. But the arrow, okay, I'm going to change colors. I'm going to change. The arrow, when I'm looking at it straight on, you'd almost like just see a dot, right? Because if it was perfectly lined up, I would only see the back end of that arrow. But everybody else in the room would actually see the side of the arrow, which might look like this, right? Stuck into the board. I got my feathers here. Okay? But would you guys, it's hard to see this on the board. We're looking at it. It looks like they're crossing right there, right? But in real life, are they really crossing?
No.
No, it's actually missing this. Will they ever meet?
No.
That's skew. So I'm gonna move to the front of the room, or look, everybody look at me. It's like, here's my line there, the purple one, and here is the arrow. Are they ever gonna meet, ever?
No.
But do they look like they meet to you?
Yes. from
Yeah.
my
Right,
side.
your two-dimensional side, right? They look like they meet, but in real life they don't. Okay? It's all about perspective. Am I on the XY plane? Am I on the XZ plane? Or what am I doing? So they're on completely different planes. Okay? Any questions?
No.
A lot of definitions. Now, here we go, guys. Again, this lesson has a bunch of sections in it. And not everything that we covered today, I don't know if anything that we covered today, is actually a question within the section. So what I did was I went here and I picked out 6 problems, maybe 7. 7 problems of prior knowledge, kind of like when we did our little review. So some of this is adding fraction stuff together, some of it's exponents. So I want you guys to do lesson 1. I'm going to call it day 1 because it's going to take us multiple days. Page 12, 4 through 10. More than likely, your problems are going to roll to the next page, like page 13. But wherever your problems start is the page I tell you to go to. Okay? When we label our homework, you better have your name on there. You better have lesson 1 on there. Day 1, day 2, day 3, that's not as important, but I still want to see page 12, 4 through 10. Because that way, if you find a paper someplace, or I say, hey, you're missing page 12, 4 through 10, you can quickly find it and post it in your homework slides. I have not set that up yet today. Hopefully by Monday or Tuesday, that will be live and it'll be ready to go.